will be less dense than water. They will float on water. Talk about their solubility, just like alkane, they are also insoluble in water, but soluble in polar organic solvents. So let's look at their chemical properties, which is also known as their reactions. Yeah, they have carbon to carbon double bond. This is their functional group, and it is what drives their reaction. So they are highly reactive due to the presence of electron-rich pi bond. The pi bond here is like an extra electron. So the electron that you have here compared to what you have in the case of alkane makes this to be more reactive. That is, the electron is more the electron is more open to attack incoming electrophile. So that is why they are more reactive or highly reactive compared to alkanes. So the reaction that they undergo, as I mentioned last time, is addition reaction. They undergo addition reaction readily because of the presence of double bond. So when we say addition reaction, we've seen it today. Yeah, it's like when you have carbon to carbon double bond, and then you add atoms across the bond. You add one atom to this, another atom to this. For example, this one has, let's say this is ethene. Ethene has it has 4 hydrogen atoms and 2 bonds between the carbon atoms. So one of the bonds will break. Usually the pi bond will break. When it breaks, we use the broken bond to add atoms across the double bond. One atom A can come here, atom B can come here. When you have AB that is reacting with your alkene or with your ethene. So let's look at a real example of addition reaction. So we have this general, let me write the general formula first, where we have CH, and then we have an alkyl group. You can start, we may not use general reaction, so let's just go. So we have our CH again, and then we have our R prime. So this one will undergo addition reaction. What are we adding this time around? We are adding hydrogen, or addition of hydrogen. You can write it this way, so to understand how the reaction happens. So I will call this one hydrogenation. Hydrogenation. So this is the number one addition reaction we are looking at in the case of alkene. So this hydrogen, as we said, they will be added across the double bonds. Like this bond will break and this hydrogen will come and come here. The other hydrogen will come and find itself here. And I said this bond will break. When it breaks, and this bond will also break, and then part of this bond will join this, and then something like this. And then this one from the carbon, and then the other electron from the hydrogen, then they join. So we are going to have, so the double bond there will not be there because it's broken already. And then you have only single product. So let's do that. Let me show you how it goes really. And yeah, so we have the product will be C, single bond C. One of the bonds is broken already. We have hydrogen here before we have R. Then we have hydrogen here before we have R prime, our alkyl group. And then one of the hydrogen atom from this hydrogen molecule will be here, and the other one will be here. So we have our saturated hydrocarbon. Remember, this is an unsaturated hydrocarbon, and here we have saturated hydrocarbon. So what makes this one unsaturated? Because of the carbon-to-carbon double bond, and we don't have that here, so this is saturated. You can use any of your alkene to represent this general formula, we can have our CH and H and then double bond CH and H. It is our ethene react with hydrogen molecule to give us ethane this time around, CH3 and then CH3, or you can just write C2H6, or you can write the display formula the way we have it up there, CH3 and CH3. So this is something is missing in this reaction that I've not mentioned, and you don't mention it in the exam, it may spell problem for you. That is the condition of the reaction. You use catalysts like nickel or palladium, if you remember, or platinum. We mentioned this in the previous course. So we have nickel. You have to mention the catalyst used for the reaction. So it's an addition reaction. They may ask you how many products we get. We're going to get only single product because we are adding to the existing atom. We are not creating new. We are not creating more molecules. We only changed the existing molecule. So we have this molecule, and then we change its form by adding more hydrogen atoms to it. That's why it becomes another molecule here. Only one product is formed in addition reaction. So what about halogenation? We are still talking about addition reaction. I can call this one 1A and then 1B. So the first one is hydrogenation. This one we are talking about is halogenation. Halogen, that is group 7 element. So we are adding a molecule of group 7 element to our alkene. Again, RCH, double bond CH2, or if you like, you can say CHR prime, react with your halogen X2. It can be, X can be chlorine, X can be bromine, can be any one of them. So let's go, our product this time around, just like the way we have it in the case of hydrogen, the halogen atoms will be added across the double bond. So we are going to have RCH, X, single bond, CH, RX, single bond. So we move from alkene, unsaturated molecule, to an alkane, a saturated molecule. This one is a halogenoalkane, which is a saturated hydrocarbon, saturated compound at the same time too. So let us use, we use ethene as an example again, CH2 double bond CH2. We are going to use bromine, Br, and then Br, with the same thing as Br2. I just break it down like this so you know how the reaction goes. So we are going to have CH2 Br, then CH2 Br. Remember, I said they will be added across the double bond. The compound is they may ask you to name the compound, is 1,2-dibromoethane. You know this before, dibromoethane. So that is the product. Another one is hydrohalogenation, 1C. We are still talking about addition reaction. So hydrohalogenation. So this should be, you are supposed to be, you should find this one easy at the same time too. This time around, instead of adding hydrogen, we are adding hydrogen halide to the molecule, to our alkene. We have RCH double bond CHR prime. This is our alkene molecule, and then we are adding any of HCl or HBr or HI, any one of them, we are adding it to the molecule. So that is why we use the general formula to represent it. I will write HX instead of X first. So HX. So that is what we are adding. This addition will follow a rule that is called Markovnikov rule. So this rule is very important in this case because one of the atoms in this molecule or in this compound is hydrogen and the other one is halogen. So you'll be thinking, where will the hydrogen go in this case? Because you cannot just add the way, remember up here we are dealing with hydrogen, we are dealing with bromine. So anyone can go to any of the two carbon atom without thinking of which one will go. But in this case now, we have two different atoms. Where will hydrogen go? Will it go to this carbon or it will go to this carbon? To determine where hydrogen will go, we use Markovnikov rule. And then the rule says that the hydrogen atom adds to the carbon of the double bond that already has more hydrogen atoms. That is, the rich will get richer. The carbon atom that has more hydrogen atom will attract the incoming hydrogen atom. So let's have a look at that. In this case, let's show. So we'll be able to use Markovnikov rule. So I will change this structure. I will write RCH double bond CH2, or I can draw it H and R, CH and H. Of course, we've seen the carbon that will welcome the incoming hydrogen atom. So let us have our HX. So when we want to add across the double bond, it's going to be C, the existing hydrogen, the existing alkyl group, the existing hydrogen, the existing hydrogen. The new hydrogen that is coming, where will it go? Will it go to this carbon or this carbon? Of course, it will go to the other carbon, not this carbon. So because the other carbon has what? It has two hydrogen atoms. This one has only one hydrogen atom. So let us put it. So it's going to be the incoming hydrogen will be here, and then the incoming halogen will come to the one that has only one hydrogen atom. That is Markovnikov rule. So we can change this one to a molecule like CH3, CH double bond CH2. This is a propene plus our HCl. So it's going to be CH3, CH, and then single bond CH2. I've not added the H and Cl. So where will the H go? Where will the Cl go? If this is carbon number 1 and this carbon number 2, the H will go to carbon number 1, of course, because it has more hydrogen atoms compared to the carbon number 2. So I will change this from CH2 to CH3, and then I will introduce the chlorine to the next carbon atom. It's going to be CH3, CHCl. All right, the Cl very well, Cl, something like this. So that is how this reaction goes. Please don't forget using your Markovnikov rule when you are talking about that. So this compound will be, let's name this compound. Of course, our chlorine is on carbon number 2, not on carbon number 1. So it means this is going to be 2-chloropropane, or so it's not going to be, it's going to be 2-chloropropane, not 1-chloropropane. So remember Markovnikov rules. And this chlorine is on carbon number 2, so it's going to be 2-chloropropane, our product.